Who has started so far? We looked at it already. What did you find? Okay. Okay, that's okay. Well, at least you got good start. No one else started yet? So let me make sure I understand. So you're going to spend 4 or 5 years of your life dedicated to this pursuit of mechanical engineering. And what I propose to you is that you should look at the whole program, figure out if it makes sense. Is it reasonable? Right? I think I asked you to do something that would make sense to you as a consumer. I hope you'll do it. Okay, so I want you to turn it in tomorrow. I want everybody to do it by tomorrow. Okay? And why don't we take just a minute in the K44, please. You're taking EAS 208 right now, right? What category would you put that in? Would you call it science, math, engineering, design? It's normally considered science. It's dynamics. It's part of physics. A special part of physics. A special part of physics called dynamics. So that's a science class. What about what kind of class is this? Science? It's not science, right? Mathematics? No. Design? Maybe a little bit of design, right? Maybe a little bit of general education, philosophy. I think so. I hope so. I hope it's worth something. The style of engineering education, as we talked about last time, and we're going to talk about some more today. Engineering education is not a very old field. Right? It's not an ancient field. It's only a few decades, maybe 2 centuries at most. And it changes all the time. Technology changes all the time. I mentioned last time, when I was a boy, there was no computer, there was hardly any television. Right? Most of what I learned as an undergraduate student is technology that doesn't exist now. I mean, it's been surpassed. A lot of the technology that's available today didn't exist even when I was a student. So what is a meaningful education? It changes all the time. So I think you should think about that all the time. You're preparing, you want to be successful. In a few years, you'll graduate and get your degree, and then you'll work for maybe 40 years, 50 years in a career. Are you going to be ready for the next 40 years? When I graduated, I thought I was ready. Okay. Things changed a little bit. I still think I'm ready. So this comes to the difference between education, training. What I hope that you will get out of this program is education. Okay. Training is when somebody tells you exactly how to do something. It works right now. But maybe in 2 weeks, 2 years, 20 years, it doesn't work anymore because it's not relevant anymore. When I was a boy, when I first learned how to drive, the inside of the car had what were called points. It had spark plugs. That's something called carburetor. That was the main functioning parts of an internal combustion engine. There was a piece on the engine that spun around, and it had 2 electrical contacts. One held still, the other one spun underneath. It had 6 places on it. When it made contact, when the 2 made contact, electricity flowed through, and that electricity went to the spark plug. The spark plug then made a little spark, and that ignited a mixture of gasoline and air. And that mixture of gasoline and air came out of something called the carburetor. If you wanted to know how to use an engine in those they've left. The ignition is from something electronic, and the gas mixture comes from something called a fuel injector. But there is no such thing anymore as something called a carburetor in a modern engine. So it completely changed. My first job after I graduated was to work on a jet aircraft engine. It was the engine that's used on Boeing 747, huge engine, 3 meters in diameter. It was a lot of fun. That engine today is almost completely different from the one that I worked on when I first started. The airplane is the same, the frame is the same, but the engine is completely changed. It's much more fuel efficient nowadays. So the technology changes all the time. So here's the point. When I first started my job with that company, I was an engineer. I was educated as an engineer. I didn't really know how that particular engine worked, but I understood all of the physics that went on inside that engine. How the compression worked, how the ignition worked, how it created extra pressure, how the turbine worked. I understood all of that. But to help me to learn how to fix that engine, they sent me to the school that the aircraft mechanics go to. Why are the aircraft mechanics there from the airlines? They're there for training, so that they know exactly how to fix that engine. I never saw that engine before in my life. I was the engineer. Right? The mechanic has to fix it every day. So the mechanic has to know exactly how that particular engine works. But while I was at the company, I was involved in designing the new engine, the one that now flies around. And then the mechanic has to learn how to fix that engine later on. So the idea of this education system, and our engineering education system, is hopefully to prepare you for a lifetime by education, not for next week by training. Okay? So that's just more of the philosophy. All right. So last time we started discussing what does it mean to be an engineer. In the old days, it didn't mean anything, right? Then slowly there was a system of apprenticeships. Finally, France started a system of formal education. And now everybody thinks engineering means getting a formal education. Who thinks that an engineer doesn't have a bachelor's degree in engineering? These days, hardly anybody thinks that. The definition of an engineer is you got a degree in engineering. Okay, that's brand new. That's not very old, but that's what we think today. So in the United States, the process for making sure that the degree is good for engineering is called accreditation. Accreditation is a formal process to certify educational programs. The system of accreditation in the U.S. for engineering, the system of accreditation in the U.S. for engineering programs is run by an organization that's called ABET. It's private. It's not part of the government. Okay? Alright, so I'm going to talk a little bit about how this works and the history of ABET. But before I do, I'm going to give you another assignment. I want you to go find out if Vietnam has a system of accreditation for universities as a whole, like all of TNUT, and also within universities for specific engineering programs. Okay, find out. And if Vietnam does have a system, find out how it works. Write a summary of how it works. I'm going to tell you how ABAT works. Okay. So when I'm done telling you how ABAT works, you'll have an idea of what's on the board. Okay. Does anybody have any question about the assignment? Well, I'll leave it up there for just another minute. I'll need that board. Okay, so ABAT does engineering accreditation in the U.S. ABAT accredits programs. That's not universities or schools or departments. Okay, what do I mean by that? If you did the assignment that I gave yesterday, and you went to the homepage of the department that offers a bachelor's degree of mechanical engineering, you found out it also offers a bachelor's degree of aerospace engineering. The department that I come from is called Mechanical and Aerospace Engineering. 2 different degrees. In order for those 2 degrees to be accredited, our department has to go through this accreditation process with ABAT 2 separate times. The mechanical engineering degree gets accredited by itself. It's one program. The aerospace engineering degree gets accredited by itself. It's another program. Okay. If we had another degree in our department, say nuclear engineering, we'd have to get that accredited by itself. That would be 3 programs. So, in the U.S., with this system, the idea is something like this. If you're an individual person and you want to become an engineer, you have to get a degree, an engineering degree, and your degree has to come from an accredited program. If you're a program, mechanical engineering, in order for you to give a degree that's valid, that counts for an engineer, the program has to have its own accreditation. It's sort of like a degree for the program. So the program goes to ABAT, and ABAT studies the program. And after it studies the program, it either says this is a good mechanical engineering program or it's not a good mechanical engineering program. If it says it's a good mechanical engineering program, you receive a certification that you're a good program. That certification is called accreditation. So now I call myself an accredited program. I'm an accredited engineering program. If I'm not accredited, and you study with me, and you get a degree from me that's not accredited, that degree will not be worth much. Most of the companies will never hire you. If you want to get a professional license in engineering, you're not eligible to even take the examination. In order to be eligible to take the examination, the first requirement is you have to graduate from an accredited program. Okay? So now the definition of engineer that we've been discussing for the last couple of days, it suddenly has become much higher legally. Right? Now it's not possible for just anybody to say, I'm an engineer. Now, first, the school, the program, has to get its own degree, accreditation. Then you have to study inside of one of those programs. Okay? Are there any questions? Yes?
I am a Vietnamese and I study in Vietnam, so I received the certification from ABAT.
No. So simple answer is no. Yeah. His question is, since he's studying here in TNUT, and TNUT is not ABAT accredited, will you have an ABAT accredited degree? The answer is no. So we'll talk a little bit about foreign accreditation in ABAT's version. Now, there are quite a few accreditation agencies now that exist around the world in different countries. And what's your assignment? Find out if something like this exists in Vietnam. If it does exist, does TNUT have some accreditation at the university level or at the program level? How does that work? Explain it. Okay. So let me explain something else about ABET. The university that I go to, that I come from, the university has a lot of programs, over 100. Medicine, law, dentistry, pharmacy, biology, history, you name it. There's 100 or so of them. The university as a whole gets an accreditation from a bigger agency than ABET. So first, in the U.S., the whole university gets an accreditation. Okay? Then, inside the university, each program gets accredited by specialists in that field. ABET accredits the engineering programs. So first, the university gets a whole accreditation, and then the individual programs get accredited. Any questions about that? Okay, now, this organization now calls itself ABET. They copyrighted the name ABET. So they're just called ABET. It doesn't stand for anything. It's just a name. But it used to stand for something. It stood for something called the American Board of Engineering and Technology. In the United States, there's two different kinds of engineering degrees. One is called a Bachelor of Science. That's what you're studying. That's engineering. There's another degree called Engineering Technology. Engineering Technology is training. It's mostly training. Engineering Bachelor of Science is education. Engineering Technology normally is not eligible to go to graduate school for a master's degree. Engineering, you can go to a master's degree, PhD, or maybe you want to go to medicine and get an MD. Maybe you want to go to law. That's all fine if you have an engineering degree, Bachelor of Science, the one that you're getting. Okay? So this organization accredits both engineering and technology. But now it's split into two pieces. So the part that accredits engineering is different from the part that accredits technology. Any questions about this? Okay. So I don't know enough about the job situation, the professional situation inside of Vietnam to know if how similar it is to the U.S. But let me tell you that in the United States, the profession that normally has the highest average salary, do you know what it is? But, yes, you do. What is it?
In Vietnam, we also have that true. The professor always is paid more than the normal teacher.
Professor makes more than a normal teacher? Yeah. A university professor in the U.S. also makes more than a normal teacher. But of all the professional people in the whole society, what class, what definition normally makes the highest salary? Medicine. It's in the U.S., it's medicine. A medical doctor normally makes the most money. Okay? Second, for a lot of people, would be lawyer in the U.S. The lawyer, though, is a much bigger range. Some lawyers actually don't make very much money, but some lawyers are very, very rich. Okay, engineering is okay, but it's not at the top. It's sort of in the middle somewhere. How is it in Vietnam? Actually, engineering, I wouldn't say it's in the middle. Engineering it's closer to the top than the bottom, but it's not the top. So maybe the same in Vietnam.
In Vietnam, we the people make business, they maybe can hire us.
Okay, well, the accreditation in engineering is very interesting compared to medicine, for instance. So if you want to become a medical doctor, there are certain things that you have to prove that you know, very specific things. In engineering, the engineering programs have to write a definition of what they're trying to accomplish, what they're trying to teach. Okay? And then, to become accredited, it's necessary to do a study and prove that what you say you're doing, that you're actually doing. say the same thing. In medicine, everybody has to do the same thing. All medical doctors are assumed to have the same expertise. But it's not the same in engineering. So I could say my mechanical engineering program, my goal in the mechanical engineering program is to prepare students to go successfully into graduate school. Okay? And so as the students go through, I have to do studies of the students, take surveys, take quizzes, see what happens to you after you graduate. And if most of the students are going to graduate school, I'm successful. If most of them can't go to graduate school, they're not good enough, I'm not successful. So if I say that my goal in mechanical engineering is to prepare students for graduate school, I can become accredited if I prove that, in fact, that's what I'm doing. But I won't get accreditation if they don't go to graduate school. So this is really interesting because this changed a lot about 10 years ago. Prior to 10 years ago, engineering was like medicine. Right? In order to be called a mechanical engineer, you needed to know a certain amount about thermodynamics. You needed to know a certain amount about dynamics. You needed to know a certain amount of math. You needed to know a certain amount of chemistry. It was a formula. It was very, what we call, proscriptive. ABET told you, well, maybe whoever told the school, ABET told the university, the program, you must have this much physics, this much chemistry, this much math, period. All schools have the same rules. Today, it's completely different. Today, we tell ABET what we're going to do. Okay, I could call myself a program of mechanical engineering, but maybe I want to focus on machinery. Right? Machinery is only one part of mechanical engineering, but maybe that's what I want to focus on. So I can say, the point of my program, the goal of my program, is to prepare engineers that are ready to be experts in machinery. You don't have to know chemistry, maybe. Maybe you don't have to know math. That's okay with ABET. There is no minimum. As long as I do what I say I'm doing, as long as you really are an expert in machinery when you graduate, that's good enough for ABET. It's very interesting. So if you go around the United States today, in mechanical engineering, you'll find something like 200 different programs that are accredited, 200 different universities. Okay? Every one of them has a different statement of what they're trying to accomplish. In theory. About 99% of them sound almost exactly the same. But in theory, they all have their own statement. Most of the statements say something like, we want to prepare our students so that some of them can go on to graduate school successfully. And some of them will be experts in machinery. Some of them will be experts in thermodynamics. Some of them will be experts in the automobile industry. Some of them will work on computers. Yeah, so it has a statement that's very, very general. And then it will be hard to miss. It's just like any other target problem. If you make the target really big, it's easy to hit. So we make a really big target. Okay. I erased it already, but again, I'll come back to your assignment. I hope that it'll be interesting to you to look into seeing what the system is in Vietnam. You're in the advanced program. You're a little bit outside of the normal system here at TNUT, but you have hundreds of friends, right, taking other classes at TNUT, taking mechanical engineering, for instance. How is the mechanical engineering program at TNUT created? How is it evaluated? Who decides what pieces it's going to have? Who decides that? Well, I want you to write a little summary report. Let me know. Okay? Now, you have an assignment to look at the program in Buffalo. It's designed for 4 years. As Jason. Casper. No, you're Casper. Yeah, what's your name?
My name is T-H-I-M-H.
10. Is that a good pronunciation? Correct me if I'm wrong. 10. As 10 said, the program in Buffalo requires something like 130 credits. I'm going to say something like, because you have to go figure it out for yourself. And I'll say something that he didn't quite say, but it has something like 30 or 40 courses in it. How did they do those 30 or 40 courses get in there? I propose to you that you look at, on that sheet that I handed out, or the assignment I gave. I think I gave, did I tell you to do this? Maybe I didn't have this on there. This is the home page of the university. On this home page is something called a course catalog. This has the list of all the courses at the University of Buffalo. There are thousands of courses. How is it that the mechanical engineering program selected 30 out of those thousands, or 40, whatever the number is, something like 30 or 40, out of those thousands? How did they end up in there? Is it reasonable? Or is it the best 30 or 40? Maybe this one should be out and that one should be in. Do you know how we decide?
Based on input of the professor.
Yeah, we have a meeting of professors. All the professors are invited. Some of them don't come. They don't want to do it. It's too difficult. But the professors come and they argue. They fight. Like, my specialization is spacecraft control systems. I'm sure that spacecraft control systems, I'm sure that's the most important thing. So out of those 30 or 40 courses, there should be some more spacecraft control system courses. Okay. I think thermodynamics isn't that interesting, so we can take that one out. But right over there is another professor. His specialization is thermodynamics. Right? He's sure we should have 4 more thermodynamics courses. We don't need any spacecraft control system courses. We just throw that one out. So that's what the faculty meeting is like. It's a big argument over what's the most important thing for the students to learn. Now, all of the professors have their own interest that they promote, but all the professors also believe strongly that they want to do the right thing for students. So they try to be open-minded, try to really figure it out and put the correct 30 or 40 courses. But the curriculum that you end up with, that 4 years that you end up with, that's just the end of a long discussion and debate among the professors. It's not magic. Like, nobody knows for sure if that's really the right one. Maybe this one should be out and that one should be back in. Right? So your job is to look at the curriculum. This was the assignment last night. Look at the curriculum, look at those courses. I want to hear your opinion about the curriculum. What do you think? And more importantly, right now, I want to make sure that you understand where it comes from. It's not magic. It's a bunch of human beings like me that give our best opinion over what we think is the most important course. But there are thousands to choose from, and maybe we didn't get it right. Maybe we missed a good one. Okay, how often do you think that the curriculum changes?
Every
10 years? 10 years would sound to me very reasonable. I wish it was 10 years. There's no law about how often it changes. In our department, I would say, based on my experience, I've been a professor there for 25 years. I think in 25 years, we've probably changed it 20 times. So what happens is, the K-44s in our school, we don't use that same name, but we could. So if we had K-44s in our school, at the time they start, we present them with a 4-year curriculum. Now that's like a contract. This is what you study for 4 years. But in the meantime, we keep arguing about it. And so we decide to take this course out, put this course in. When K-45 comes, they get a 4-year curriculum that may not be the same. So K-45 may do something different from K-44. Right? And then K-46 comes, and they have something different. Then maybe for 1 year, nothing changes. But then we change something else, and K-47 has something new. Yeah, it's crazy. It's modern technology, right? It changes all the time. What's the most important thing? I told you before, when I first took my computer class, I learned on what's called a slide rule. It's sort of like an abacus. Okay, well, in the modern computer world, that's crazy. Get a computer. We used to have a course on slide rule. We don't have it anymore. Some things don't because that's solid, it's reliable. You can use that for the rest of your life. If you spend too much time learning how to use your computer, that's only going to help you for another 6 months, 1 year, 2 years, because there's going to be a new computer. You're going to have to learn how to use the new one anyway. Right? So maybe that's not a good use of your time. Maybe it's better if you learn calculus. I have currently a minority view in most of America. Most of American engineering education is shifting more towards things like today's computer and farther away from things like calculus, physics. Physics doesn't change. As far as we can tell, the physics of the universe has been the same for the last 13 billion years. What are the chances it's going to change tomorrow? Probably not very much. But the computer changes every 5 minutes. Okay. A little long-winded. Any questions or comments on this? I'd like you to answer this question very honestly for me. Who thinks this discussion is interesting? Anybody? Okay, thank you. I hope it's interesting, because I hope that you're going to be a good consumer, as I've said over and over again. Right? You need to always have an open mind and think about what you're doing and make sure that it makes sense in the long run. It's not a fixed program. You just do this and this and this and this. You always have to think creatively, always. And that includes even the education itself is creative. Okay. So ABET uses a system of self-study. Okay, how does the system work? First of all, each university has to do, each program has to do what's called a self-study. You have to compile a huge book, or maybe 3 or 4 books, thousands of pages sometimes, of documents that measure your program. Okay, what are sometimes called metrics. Metric is just a kind of a fancy name for measurements. So some of the things you might measure, for instance, are what percentage of the freshmen, the people that come in at the beginning of the program, actually graduate at the end of the program. If it turns out that a lot of the students don't make it to the end, for whatever reason, maybe they don't like it, so they quit. Or maybe they can't do it. They're not good enough, so they fail out. But for some reason, they don't make it to the end. If too many students aren't making it to the end, that's a problem. Right? So you document that. In each individual course, you document what the course is supposed to accomplish and what the students get out of it. So for instance, in EAS 208, there's a statement as to what this course is supposed to teach you. You're supposed to learn something about dynamics. At the end of the course, do you know anything about dynamics? You don't think so? Okay. Not yet. You're not at the end yet. So the self-study would have, for instance, the syllabus of the course explaining what it is that it's supposed to happen, and then at the end, making copies of the final examinations of 5 students, picked at random. And let's see if these students really know what they were supposed to learn. Okay? The self-study is full of that kind of stuff. It has information about the faculty members. Are the faculty members staying up to date in their profession? Are they active? Do they write papers in journals? Go to meetings? There's information about the facilities. How are the labs? Do they have good equipment? Is the equipment working? If it breaks, do they fix it? Do they have new computers? Reasonably new computers? Right? All kinds of information like that is in the self-study. Then one of the most interesting things, and this is true in a lot of engineering practice, One of the most interesting things is that the evaluation is done through a system that's called peer review. Who knows what this means? Don't know? Yes? Yeah, an equal person. Peer means an equal person. So the peer review, the peers normally are mostly professors from other universities around the United States. Okay, sometimes some foreign professors are invited, sometimes people from industry are invited, but the majority of them are professors at other universities. And a committee is formed with the peers. And the committee comes to the campus and they read the reports. They read the self-study report. Then they go and they talk to people around the campus. They might come into a room like this and make me leave, ask the professor to leave. And they ask the students specific questions about what you're learning. How's the program? Then they ask you to leave and they ask me questions like that. And they go and they talk to the provost and the dean, the rector, the vice rector. And after a few days, then these peers, right, they write a preliminary report. This is our evaluation. They list the things that they think that are working well and things that aren't working very well, the problems, right? Preliminary shortcomings, weaknesses. That's a commonly used word. Weakness. What's a weakness in the program? They might decide that a weakness in the program, just as an example, a weakness could be that there's not a good library. Students don't have anywhere to go to read additional work in the library. It could be that there aren't enough computers. It could be that there's not enough lab equipment. It could be that the faculty is not active. They're not good. Right? They're not doing other research or other scholarly work. But whatever it is, they identify weaknesses. Then this preliminary report gets sent to the university. Now the university gets usually something like 3 or 4 months to carefully prepare a response to this. And they can say, for instance, we agree that the library is not very good. So we promise that we're going to go buy some books. Or maybe they go buy them right away. We agree the library is not very good, so we already bought books. Put them in the library. We disagree that the computers aren't good. Our students have great computers. That's not a problem. The peers made a mistake. That's just not true. So they might agree, they might disagree, but they write a formal response. Then back at ABAT, the committee, the peers, look at the response and they write a final recommendation. That final recommendation is you get accredited, you go on probation, you don't get accredited. Okay, there are three possible outcomes, and there's 2 of these kind. Okay? Under the ABET system, the best accreditation, the best one that you can get is for 6 years with no further review. Okay. If they think that your program is okay, it's not too bad yet, but it has some serious weaknesses, some serious concerns. They might say, okay, you're accredited, but for some time period less than 6, and there will be a new review. And it could be just 1 year, anywhere from 1 to 5. Now, it's rare in those cases for it to be more than 3 years. Because if they're not going to review it again in 3 years, they might as well wait 6. 4 years and 5 years, there's no real point in that. But it's not unusual to have a 1 year, 2 year, 3 year review. Okay, and then you have to do the whole process all over again. And you have to prove to ABET that you fixed it. The things that they said were weaknesses, that you did something about it. Okay? Any questions? Yeah, the last one is that you lose accreditation. You're out. Now you can try again in the future. Yeah, you can try it again, but you lose it. It's It doesn't happen very often. It's more common that it would happen on a new program and trying to be accredited for the first time. They would not grant accreditation. But if you've already achieved accreditation, normally you have to be pretty bad for a little while to lose accreditation. It doesn't go away very quickly. Okay. Now, at a university like Buffalo, we're kind of a middle-sized university in engineering because we have all the fields. Engineering is kind of middle-sized compared to the U.S. Guess how many ABET programs we have? Remember, we do it program by program. And I already told you two of them. Mechanical engineering has ABET accreditation. Aerospace engineering has ABET accreditation. So we go through this process for all of our ABET engineering degrees. Guess how many we have? 100. 100 degrees? How many engineering degrees are in TNUT? There's mechanical engineering. What else? Electrical? Technical teaching? Yeah, technical teaching probably wouldn't be an ABET. Electrical engineering would definitely be one. Civil engineering could be one. Environmental engineering could be separate. In the U.S., sometimes environmental engineering is part of civil, sometimes it's separate. Okay, so here's an interesting question, and I think it's interesting, if you don't agree. How many different programs do you think ABET allows you to have? In other words, all of the engineering programs that are possible anywhere in the United States to get ABET accreditation. So let's see how many we can name these. Let's have fun with this one. Mechanical, aero. Okay, I did two. We'll all do two. So I did mechanical and aero. You do two more. Just one more. Electrical. Okay. Mechanical, aero, electrical. Yeah, electrical. Electronic engineering is a separate one. Civil engineering. Okay, we'll go with the category. They have electrical and electronics. Okay, computing engineering, computer engineering. Environmental engineering. What are some other kinds of engineering? Technology is separate from engineering. What are, I think, is the big fields of engineering? Agriculture. Okay, agriculture. Agricultural engineering is one. Mining engineering is one.
have a ship.
Ship? Yeah, it could be, we'll call it marine engineering. Alex, is that computer online? Is there a wireless signal? Is your computer online? Yeah? Can you do a web search for me? Yeah, do. Search ABET. Yeah. Okay, what else? Manufacturing engineering. Think of one big field that's completely missing up here. Yeah, there probably is something like water engineering or water resources engineering. That's often part of either environmental engineering or civil. Not usually it's a major. Yeah. Biomedical. What about, what's a big part of biomedical engineering? Or not even the bio part, just the chemical. Underneath chemical, there's a separate one, something called petroleum. Right? That's a huge field. What else? We have civil. Industrial. Did you look at ABET? Which one? Facilities? I didn't hear. Sorry. Why don't you come right? Okay, I'm going to read the list. I'm not going to write them all. Okay, I'll read the list. We have the official ABET list. So, what's important about this list in the United States? In the United States, every program that's going to have ABET accreditation has to sound like one of these on the list. Okay, this defines the name of the program. If the name of your program doesn't match this, you can't get ABET accreditation. All right, here are the names. Aerospace engineering, we had that one. Agricultural engineering. Architectural engineering. Right, what's architectural? It's like buildings or something, right? But it would be a specialty inside of civil engineering. Bioengineering and biomedical engineering is one category. Biological engineering. Ceramic engineering. What's a ceramic? It's a material made out of something in particular, right? Glass. Chemical engineering, civil engineering, computer engineering, construction engineering. We did that. Electrical and electronics engineering, one category. So these two go together. Engineering management, like the business side of engineering. Engineering mechanics. like EAS 208. And by the way, engineering mechanics, that's what my degree is. Engineering physics, environmental engineering, fire protection engineering, forest engineering, geological engineering, industrial engineering, manufacturing engineering, materials engineering, mechanical engineering, metallurgical engineering, different kind of materials, metallurgical, mining engineering, naval architecture and marine engineering, nuclear and radiological engineering, ocean engineering, optics engineering, petroleum engineering, photonics. What are photonics? Photonics engineering. Photonics are anything that combines electricity and light, right? Like solar panels. Software engineering. Surveying and geomatics engineering. That's a subspecialty in systems engineering. Telecommunications engineering. And welding engineering. Okay, that's the list. That's the whole list. So maybe this would be something interesting for you to discover about the Vietnamese system. Maybe it wouldn't be so interesting. Yeah, maybe something interesting to discover about the Vietnamese system is there a similar list? Because I can tell you that for many years I was in charge of all of our international programs at our university. That's how I came to know T and UT in the first place. And how we started this program, just because I was in charge of international programs. I had a lot of dealings in Europe. In Europe, you can find maybe 200 different names of programs all around Europe. In the United States, they have to match that list. That list has about 30, maybe 35 different names. All of the engineering programs have to fit into one of those names. In Europe, there's a couple hundred different names. What's the system in Vietnam? Do you know? You don't? I think you should. Right? I think it's part of becoming a professional engineer, is that you would know something like that. So that's why I gave this assignment. I'd like you to figure that out. Okay. A few more facts about ABET I'll mention. Some are more interesting than others. When do you think ABET got started? Yes. So we talked about how there was no formal system, just apprenticeships or something like that, but no formal system of engineering, at least until something like the early 1800s, when it started in France. In the late 1800s, it started in the U.S. Did I talk about the land grant? Did I mention land grant? Oh, let me talk about that for a minute. As you may or may not know, the United States had a huge civil war during the early 1860s. And at the end of the Civil War, there was destruction in many, many places, really bad destruction. So to help recover a little bit, one of the things that Congress did was they passed something called the Morrill Act. This is just a guy's name, Morrill, just the name of the senator that proposed it. Okay? And what what this law did was, in every state that existed in the United States at that time, the federal government owned some of the land. The federal government took some of the land that they owned and they gave it back to the state so that the state could sell the land and create a new university. So those grants were called land grants. And every state ended up with a big university that was called then the Land Grant University. And to this day, they're still called the Land Grant Universities. You can go all around the U.S., at least in the eastern part, and you can find every state has a big land grant university. And you've heard of most of them. Michigan State, Ohio State, Penn State. Most of them have the word state in them. And they were land grant universities. They were huge universities. But there was a rule about these universities. They had to focus on, because they were trying to recover from the Civil War, they had to have two main focuses. One was agriculture, and the other was technology. So prior to the U.S. Civil War, there were a relatively small number of specialized schools. They were private, they were not public, and a few people got to study engineering, but not very many. After the Civil War, every state had a large university that included technology. So all of a sudden, engineering education was all over the U.S. So it was really that act that really started formal engineering education in the U.S. So that's in late 1800s. Maybe by something like 1880 or 1890, every state has a big university giving engineering degrees. 1880, 1890. Okay, so when did ABET start accrediting the programs? 1932. Okay, so it took 40 years or 50 years for the system of accreditation to come into existence. For those first 40 or 50 years, how did you know that you were getting a good engineering degree? You didn't, right? I mean, you just took your chances. Okay. Now there's this formal system of accreditation. You have to get an accredited degree. Okay. Any questions about this part? Does everybody understand the difference between a public and private university in the U.S.? Yeah, the public is run by government. The distinction these days is getting sometimes a lot more difficult. In the early days, the public university usually was funded completely by the government. Most of the students that went to the university didn't really pay anything. It was free. But over the last few decades, the system has really changed because the government wants to put less and less money in the university. So all the universities now charge students. They all have to pay, whether it's public or private. And they also go out and they try to make money in other ways, like through sports teams or just donations. They just go to some rich guy that graduated 20 years ago and ask for money. Or it works sometimes. So that now some of the big public universities that are very successful, and I would say my university is one of these, even though it's officially a public university, the percentage of the budget that comes directly from the government is actually very small, maybe 10%, 20%. 80 or 90% comes from somewhere else. So it's almost like a private university, really. But officially, legally, it's still a public university. It's still owned by the government. Okay? So in the early days of these land-grant universities, these were definitely all public universities. Nowadays, like I said, it's a little harder to tell the difference sometimes. All right. What else should we know about it? Anything? I'll mention one other thing about these degrees. ABET is made up mostly of professional engineering societies. Do you know what professional engineering societies are? You can probably guess. They're organizations, they're voluntary, you're normally not required to join, but people that practice a certain profession, it's often very advantageous to you in your career. become a member of the society, professional society. So in mechanical engineering, does anybody know the name of the professional society for mechanical engineers in the U.S.? It's very famous and it's huge. In the United States, mechanical engineers have their own society, and it's called the American Society of Mechanical Engineers. That's not a very tricky name. It's actually a pretty easy name. ASME for short. Okay, not all of the mechanical engineers in the U.S. are members, but a lot of mechanical engineers are members, and students can join this society. Students can be members of ASME. There's something called student membership. And I haven't done this yet, but I think I will look into whether or not you all are eligible to join. Maybe you'd like to become a member of ASME. Let me just mention a few of the others. For aerospace, there's something called AIAA. That stands for American Institute of Aeronautics and Astronautics. For electrical engineering, it's called IEEE. Institute of Electrical and Electronics Engineers. For civil engineering, it's called ASCE, American Society for Civil Engineering. Computer engineering, I don't think there's a single one. I think there's a lot of different ones. Environmental engineering, I don't really know. Probably part of ASCE. Yeah, this one I know is called ASCHE, American Society of Chemical Engineering. This is called, I think, IES, Industrial Engineering Society. Anyway, there's I don't know how many of these there are, maybe 20. They're all private. They're all private. They're not from the government. And they survive mostly by dues. So for a professional person like me to be a member of American Society of Mechanical Engineers, it costs something like $100 or $150 every year that I would pay to be a member. For a student, I think it's something like $15 or maybe $20. Okay, and all that money goes into a pot. Now, what ASME does, we're going to talk more about ASME on another day, but ASME is the major professional organization for mechanical engineering. One of the things they do is they publish lots of different journals and magazines. So there's one magazine they publish that comes out every month. If you become a member, you'll get that magazine. And it has general news all about mechanical engineering. It also has a section of jobs in it, which is nice. You can look for a new job in there if you want for mechanical engineering. That kind of information. But it also publishes, I don't know how many, I'm going to say maybe a dozen, something like that, specialty journals for different specializations inside of mechanical engineering. So one for thermodynamics, one for dynamics and control systems, one for structures, and so on. Okay? So it's where research or new information can get exchanged among mechanical engineers. They also sponsor a lot of conferences every year where engineers can come together and discuss their work. And some of these are general conferences open to everybody, and some of them are very specialized for people that work in a very narrow field. And they're at a very high technical level, right, for the real experts in that field. Okay, so we'll talk more about ASME. Whether or not you join ASME, I think you should look into a professional society at some point in your career. And maybe something else you could do along with your accreditation study. Maybe you could figure out if there's something like the Vietnamese Society of Mechanical Engineering. Why don't you see if there is such a thing? Okay. And if there isn't such a thing, where are the professors? Where are your other mechanical engineering professors? What societies are they members of? Okay, because honestly, I'm not sure, but maybe there's something inside of ASEAN. Maybe ASEAN has a society of mechanical engineers. I know, for instance, in Britain has a separate society for mechanical engineering, not part of ASME. There's one in Germany, separate society. So maybe the professors here, there's one in Russia. There's one in China. So maybe the professors here, some of them join the ASME, maybe some join the Russian, maybe some join the German. I don't know. Ask them. Okay. Alright, so one more piece of information I'll give you about ABAT. ABAT currently accredits 3,100 programs. So we saw the list. There's about 30 specializations, right? Maybe a little bit more. So on average, something like about 100 programs per specialization on average. But it's not even. Like I said, mechanical engineering, I should know the number, I'm sorry I don't. But I think in mechanical engineering it's the biggest. And maybe it's something like 300. I think I said 200 earlier. But I think maybe there's something like 300 mechanical engineering programs. So 10% of all the engineering programs. Right? Something specialized like mining engineering, there would be a much smaller number of accredited programs because there aren't as many around. Same with marine engineering. And by the way, something else I'll mention that might be interesting for you to figure out or look up. There are these 31 or so different specializations listed in the US. I mentioned a couple hundred in Europe. What percentage of all engineers are mechanical engineers? Well, all of the good ones. 100% of the good engineers are mechanical engineers. That's a joke. The percentage varies, of course, depending on where you are, what the local environment needs, what the local business community needs. So you might have in some areas, you might have a lot more aerospace engineers, in some areas more mechanical. But overall, if you add it all together, at least in the United States, mechanical engineering is the biggest. It's got more students than any other field. For many years, the biggest was something else. Can you guess what it was? What do you think would be bigger possibly than mechanical engineering? Civil is big, but it's never been quite that big. Well, computer was part of this in the early days. In the early days of computer, it was part of something else, and then it finally became separate. It was part of electrical. So for many years, electrical had the biggest number of students. Now, electrical and computer is divided, and mechanical is the biggest in the United States. I don't know what those numbers are for Vietnam. It might be something you'd be interested in knowing. I think I asked you before what your plans are after graduation. One thing that students do a lot in the United States, they're always looking 4 years later at the job advertisements. Who's getting hired? Are there a lot more jobs for chemical engineers, mechanical engineers, electrical engineers? Because maybe I changed. I started out as mechanical engineering, but it looks like all the good jobs are going to be in chemical engineering. So I'll change and become a chemical engineer instead. So in the United States, it's common that the students are looking at the market, the job market. How many graduates, how many jobs there are. So let me ask you this, have you been doing that? Has anybody here done that? I asked you a few days ago, why did you pick mechanical engineering? If I asked that question in the US, a lot of students would say, because I think there's a really good job. Right? How many of you have that as your reason? Okay, so a few of you are thinking about that. And the rest of you have some other reason. Yeah, that's fine. I'm not trying to talk you out of your reason. I'm just saying a cultural difference between here and in the US. In the US, culturally, a lot of students would have picked which engineering they're going to be only because of the job, not necessarily because it's something they're really interested in. I think it's a mistake myself. I think you should do what you're really interested in. Don't worry about the job. You'll find something. But if you really want to have misery in your life, pick a job that you hate and do it for the next 50 years. That will make you pretty unhappy. That'll make you more unhappy than picking a job you really love, and maybe you don't make quite as much money, but at least you really love your job. That will make you happy. Okay? But in the United States, it's very common for students to pick your engineering only because of the job. And then 10 years later, they're doing something else anyway. Okay. One other thing. These 3,100 programs, these are spread over approximately 600 universities. Okay, so I asked you a little while ago how many ABET programs you thought Buffalo had. So from this ratio, you can see that an average university would have something like 5. Okay? Buffalo has, I think, 9. I think we have 9. A really, really big school of engineering in the United States. The biggest, anybody know the names of the biggest schools of engineering in the United States? By big, I mean just in terms of size, the number of students, number of departments. MIT is big, but it's not one of the super biggest ones. I think the biggest one of all is Texas A&M. And I think the second biggest one is either Georgia Tech or Purdue. Have you heard of any of these schools? Okay, well, they're all famous in the U.S. Those kinds of schools might have something like 15, even 16 or 17 ABET programs. I don't think anybody has 20. So there are 30 possible, but the biggest university in the U.S. only has about half of them. And a nice sized medium university like mine has about 1/3 of them. So depending on which specialty you want to study, you would have to go to certain universities. You can't just go anywhere and get a specialty. And I'm sure it's the same system in Vietnam. I asked you what the engineering majors are here, and I'm not sure we had a very good answer yet, but it sounds like there aren't more than about 3 or 4 at TNUT. So maybe if you want to study chemical engineering, for instance, you can't go to TNUT. You have to go to some other university. Same thing in the U.S. So the average is about 5 ABET degrees per university. Okay, now let me talk a little bit about international. Because you asked about getting an ABET degree here. So for a long time, what ABET did was something called substantial equivalency. As you probably know, the United States has a long history of receiving immigrants from other countries. And a number of those immigrants that have come to the U.S. have engineering degrees from their home country. But ABET would not, for a very long time, ABET did not accredit any program outside of the U.S. Only programs inside of the U.S. for ABET. So how could we tell if a student coming from another country had a degree that was something like ABET? So ABET started a program called substantial equivalency. And the evaluation worked exactly the same. The evaluation of the program was done exactly the same way: a self-study, peer review, site visit, etc. But at the end, you couldn't get accreditation. But if you passed, ABET gave you something called substantial equivalency. This meant that you were equal to an ABET-style program in the United States. So ABET would do that, just like inside of the U.S. ABET does that, or used to do that, one program at a time. So for instance, TNUT Mechanical Engineering ABET could come all the way here at a time when evaluate the mechanical engineering program, say this is substantially equivalent. You could be declared substantially equivalent. Then if you got your degree here, if you came to the U.S. with that degree, it would be treated as if you had an ABET-like degree in the U.S. You would be eligible to go to try to get a professional engineering license. And you would also be eligible to go into graduate schools that require that you have your undergraduate degree from an ABET university. Some U.S. graduate schools require that the undergraduate degree has to come from an ABET program. Okay? Okay, now starting in about, I think, 2003, let me put a question mark because I'm not positive about the date, but it's not very long ago. ABET accredits foreign universities, non-U.S. programs. So today, it's possible to get a real ABET accreditation. The problem is it's very expensive. And all of the accreditation has to be done in English, which means that all of the program self-study has to be done in English. And because a lot of the program self-study means the results of classes and courses, all of the classes and courses have to be done in English. So it would be possible for the advanced program here to apply for ABET accreditation. It would not be possible for the regular mechanical engineering program to apply for accreditation because it's all in Vietnamese. ABET won't evaluate it. ABET will only evaluate it if it's in English. Okay? But it is possible for this advanced program someday to get ABET accreditation. All right, any questions about this part? So that's ABET accreditation. Now there's another angle to this. It's very time-consuming and also very difficult to evaluate each individual program in all kinds of different countries. So ABET is a member of something that's called the Washington Accord. What the Washington Accord is, in a lot of countries around the world, there is an accreditation system. Okay, something like ABET. Each country has its own system. The systems that agree with each other that they're about the same, that they have the same quality standards, have signed an agreement called the Washington Accord, so that it's not necessary for every university in another country to get evaluated by the accreditation agency in another country. If your own accreditation agency says you're okay, then at the agency level, they'll take their word for it. So now, for instance, in England has an accreditation system. The UK has an accreditation system. Everybody that gets accredited under the UK system gets credit for ABET. ABET says that's good enough. Same thing in Mexico. And a whole list of countries, and let me give you a list. I'll write some of them I know off the top of my head. I'll write it while it's loading. Japan is in this. Canada. UK. Singapore. Taiwan. Malaysia. Still loading. Okay. Korea. Trying to think of who they all are. I'm not going to remember all of them. Washington? Okay. So I think it would be interesting for you to find out what the accreditation system is in Vietnam. And maybe it would be, if there is one, would they be interested in joining Washington or joining with AMED and these other countries? So these countries now have all officially recognized that each other's engineering programs are equivalent. Okay, that's the implication. So let's step back for a minute. I know we've gone over a lot of details today, and I also can tell everybody's getting a little restless. This is only half an hour early instead of 1 hour early. Now that you're used to going 1 hour early every time. In the big picture, we're talking about kind of the whole theory of what is an engineer. We started by, first of all, trying to decide what engineers even do, right? And what do engineers do? What's one sentence for what engineers do? They design, right? What else do they do? They design for what purpose? For human needs, right? And not to study the world it is, but to create the new world, right? That's what we're doing. We're trying to create the new world. So now how do we decide who is an engineer? For most of history, there was no definition of who is an engineer. Now, just in the last century or century and a half, we've come to this crazy system now, right? Where in the United States, at least, it's a very legal description of who is an engineer. Did you graduate from an AMED school? You're an engineer. Did you not graduate from an AMED school? You're not an engineer. Okay? It's completely different from where it was in history. In history, if you made something, you were an engineer. Okay? And a lot of the rest of the world is also going to a much more formal system. So all of these countries have their own accreditation agency inside. They accredit their own programs. And not only that, but they agree with each other that from now on we will recognize each other's accreditation. So if you have accreditation in Singapore, it counts in the U.S. If you have accreditation in New Zealand, it counts in the U.S. If you have accreditation in South Africa, it counts in the U.S. And the other way, U.S. accreditation counts in South Africa, in Canada, and Japan. Okay, so now we have this big legal framework in the world forming for what it means to be an engineer. Is it a good thing? Probably it's a good thing. I hope so. I hope it raises the standard and helps people understand what an engineer is. I'll end with one last little story. We talked earlier about who makes all the money in the U.S. anyway, and apparently maybe not different in Vietnam. At the top are doctors. And doctors have a very, very strict legal definition in the U.S., probably also in Vietnam, of what it means to be a doctor. You must have a certain license, pay for the licensing fee. However, if you're a doctor, you can charge a lot of money for your service. And so most doctors make a lot of money. When I was a student your age, I had a professor that was 90 years old. And his entire life was dedicated to the same idea of engineering. He said engineers give away the expertise too cheap. What engineers need to do is something like what doctors do. You need to have a very high legal standard. You can't call yourself an engineer unless you meet this very high standard, just like a doctor. But if you do meet that standard, then your service will cost a lot of money. Right? There won't be so many people that meet that standard, and you can charge a lot of money for your service. Right? That whole idea is this idea of a profession of engineering. That engineering really is a legal definition, not just a concept, but it has a law behind it. Either you are an engineer or you aren't an engineer. It's a law. Right? We're not quite there yet, but this kind of stuff gets us closer and closer to that standard. Okay. Let me tell you something else he told me. He graduated in 1927. That's hard to believe these days. But he graduated from the university in 1927. Engineering in those days was 4 years. 4 years of engineering study, just like it is today. Right? Your advanced program is 5 years, but 1 year is English. Right? 4 years of engineering. In 1927, the periodic table for chemistry, the one we're all used to, hadn't been invented yet. It wasn't even invented in 1927. No computers. There were hardly any airplanes. There really weren't very many cars or trains. Engineering in those days was 4 years. So he used to tell me when I was a student, 30 years ago, it's crazy. Because the amount of knowledge, the things that you need to know about, between 1927 and when I was a student, he said, you should study for at least 6 years. That should be the minimum. The first degree, 6 years, not 4 years. That's what he told me when I was your age. So what should I tell you? How long should you study? Because when I studied, if this was the knowledge, now it's like this. So if he studied this much and that was 4 years, I should have studied this much for 6 years. Maybe you should study 8 years. In the United States, it takes 8 years to get a medical degree. At the end of 8 years, lots of money. So maybe it's not a bad idea. Maybe engineering should be 8 years. Yeah, maybe. Okay. Thanks.